I think many of you have already taken notice of the two models I'm holding in my hands. They are all 3D printed by my company, and these models are all highly connected to food and beverage industry, and I will explain it in detail what they are for. 3D printing industry started more than 2 decades ago. The first 3D printer was manufactured in 1988, but it was not until a few years ago was it widely accepted. Even so, there's still a great deal of doubts or expectation for 3D printings. So I would like to today brief you on 3D printing and its connection to food and beverage industry. First, a few quick words about my company, Stratasys. I was founded in 1988 by an American at his personal kitchen. He manufactured the first 3D printer called FDM, and then he founded a Stratasys based on that. And in 2002, it merged with an Israel-based object company. So that's Stratasys. It's the world's largest industrial-grade 3D printer manufacturer for industrial application. We got 2 headquarters, one in US, the other in Israel. By 2015, we've got more than 140,000 machines applied worldwide. We also pay very close attention to R&D. We've got more than 800 patents. And every year we invest tremendously in new product technologies and materials. Our customer base is also wide-ranging, including automaking, aviation, healthcare, dental education, B2B and B2C. We have 2 key technologies, one's PolyGem and the FDM. And the 2 major technologies have got their own focus of preference. The first one, FDM, it could enable the 3D printing of some very solid model. Our current strategy is to make sure this technology will permeate into all the vertical industries, including automaking industry and the aviation industry, because our technology could have some profound cooperation with them. We could produce something that only 3D printer could produce for them. And we not only work with them in aviation and auto industry, but aviation is critical. For example, Airbus has used our 3D printer to directly print out more than 1,000 parts and components that are directly mounted on A350 aircraft. You know, aircraft grade product, if they can be 3D printed, their requirements are very high. We use Autumn 9085 material. The reason that the material is good because it's very rigid. It's something related to aviation aluminum, and also it has passed many different certification. Most importantly, it passed the FST certification. What does that mean? It means it's inflammable. It cannot burn at all. And S is smoke, and T is toxin. And even if it's releasing a little bit, a tiny bit amount of gas after it's burned at a very high degree, well, the gas will not contain any toxin. So in that case, it meets all the requirement that's required of an aircraft like A350. And we also invested tremendously in many different other sectors beside aviation.
然后我刚刚说到，我们这个3D 打印行业其实是对于我们各行各业都是有服务。我刚刚只提到了我们汽车、航空航天。
I just mentioned aviation, but in food, beverage, and the healthcare industry,
也是提供了非常多的解决方案。
we also provide numerous solutions.
我先来简单介绍一下我们增材制造，也就是
First of all,
的一个简单
briefly
以及我们3D 打印
on our procedure,
产品的设计当中满足一些怎么样的
as well as what kind of needs 3D printer could meet.
概念模型。
First,
我们知道
prototyping.
设计一个产品，
We all know that in the design process,
产品放到消费者手里，这是需要
from
长的流程。
from the mind of a designer to the real product, it contains several different steps. The first step involves a prototype, which means the designer could translate his or her idea into an object, and the prototyping process could be facilitated by 3D printer. And that was just a proof of concept, because it shows the form, but it's not enough. Shape or form is not enough. We also need a structure. So if you need some structural design, then you have a proof of structure and a function. That kind of prototyping can also be enabled by 3D printing. And third, manufacturing tools. Any products, if they are 3D printed, they also need to be assembled on assembly line, and they need some bending or injection, and that can be facilitated by 3D printing. And the last one is manufacturing parts and components, like the ones I just mentioned a while ago, used on A350, and some large-scale auto-making industry like Maybach and some Japanese automakers. They just directly use the 3D printed objects by us. And now I would like to focus a bit on healthcare and food and beverage industry. First, the proof of concept.
Well, it looks very beautiful, and it is latest launched a prototype of sushi printed by our latest 3D printer. And if you go to Japanese noodle shops, you will see such kind of models displayed. But in the past, it's really very complicated to make such a model, and you have to outsource it to specialized plants or factories. It takes a long time, and if the store, the shop are going to add new products, then it will take you more time to do that. But if you use 3D printing, all food model can be printed very easily. You can scan an existing model, and you receive the document, and you design the texture of it, and that object can be printed very easily, and it can save a lot of time. This is the detailed picture of that sushi model, and it looks like the real one. You can see the texture, the vivid color of salmon, and this model is printed one time. It is not printed multiple times. On the right is the lollipop that I bring with me today, and it was printed by me myself in my company. There is a story to share with you. I tried to print a number of lollipops for an event of our company, but it was refused or rejected by colleagues because they say that it looks very real, and the material is plastics. But if it looks so real, when our clients bring it back to their home, their children will eat it, and it's not safe. So I would like to show you the lollipop that I print. You can feel it. These are the two examples printed by us in a three-dimensional way. It's still on the stage of conceptual design, and the second stage is the functional stage. Thermos is a very well-known Japanese brand in China, in Japan, and it was founded in 1904. It has over 100 years of history, and it produced different kinds of thermometers. And I think some of you bought these kind of products before. But in order to produce a high-quality product, the entire R&D and the production process would be very sophisticated. How can Thermos keep its leading position in such a competitive market? Several years ago, it introduced the 3D printers of Stratasys for our company, and they use our printers to better improve their products. They introduced FDM equipment of us several years ago. As I said, that this printer is very good at printing ADS, PCA, and nylon, as well as other industrial materials. And they use our technology to do their R&D work, to test their design structure, the validity of their design and their structure. And after using our printers, they found that it's really very useful for their R&D work. And we know that some soft plastics is also widely used in their business. So the requirements of these materials are very high, and they are interested in Polyger, one of our other products, which can print some soft and transparent materials so as to improve their product. For example, they can use this printer to directly print some transparent and soft texture material to observe the fluidity of water in their products. And our 3D printers help this company to meet the highest requirements. In the past, when they make such a prototype, it takes several days, but now they only need several hours, and the cost is saved by a large margin. The cost is reduced by 4/5. And these are the applications of our 3D printers in some manufacturing areas. We know that plastic injection is a very normal practice in the production area, and it is also used by food and beverage companies. So the injection molding is inevitable. However, in early R&D stage, the molders used for injection molding is really very expensive. Sometimes it takes millions of dollars. And if the molder is not good, and if you want to improve it, it will take you a lot of time. Then Stratasys can provide you a solution. We can direct print such mold. It can help you to test the validity of the design of the mold, and if we find that the design is not incorrect, you can improve or correct it immediately, and it will only take you more than 10 hours to print it, and the cost is very low. Another application is blow molding. I will show you a video about the entire process of blow molding, and I want to display or demonstrate such a mold printed by our technology to all of you. This is a digital ABS mold, and the surface is really very good, and it's perfect for blow molding. This video is about the use of our blow molders.
Tends to be slow and costly, so blow molding companies often skipped prototype molding. The same is true for short-run production. Additive manufacturing, or 3D printing, is an effective prototyping process when evaluating blow-molded part designs, but 3D printed materials cannot simulate the properties and appearance of common blow-molded plastics, such as polyethylene, polypropylene, PET, and polycarbonate. Also, long and sometimes complex secondary processes are required to finish 3D printed parts to mimic the appearance of production goods. To keep cost and time at a minimum while manufacturing blow-molded parts and production materials, substitute PolyJet 3D printing for mold making. PolyJet molds work for extrusion, injection, and injection stretch blow molding operations. All of these processes use air pressure to inflate heated plastics so that it conforms to the mold cavity. That's how blow molding can make hollow, thin-walled parts. For extrusion blow molding, a tube of plastic, which is called a parison, is pinched between the mold halves. Injection blow molding adds an additional step. A plastic preform is injection molded and then transferred to the blow mold. Injection stretch blow molding stretches the injection molded preform after entering the blow mold. The mold making process begins with mold design, and only a few minor adjustments are required when using PolyJet. Next, print the blow mold. The printed molds can be freestanding or mounted in a mold base. In many cases, the printed molds are ready for manufacturing. But when appearance is critical, a little light sanding and buffing of the mold cavities is an option. Next, mount the mold on the blow molding machine and start molding parts. Since the plastic PolyJet molds don't dissipate heat as well as metal molds, occasionally blow air on the mold halves to cool them. That is the only required adjustment to the molding process. After molding, trim any flash and remnants of the parison. Your blow molded parts are now ready for functional review or product distribution. Replacing machined metal blow molds with polyjet molds allows companies to make bottles, containers, and many other products in end-use materials with up to 95% reduction in time and cost. For further information, contact Stratasys Application Support.
好，大家刚刚看到的就是我们打印出的这个数字 ABS 吹塑模具，
This is the digital ABS blow molding
然后我们这个吹塑模具
case.
呢，它可以吹大概1到1000个这个瓶子都是可以没有问题。
And it can blow 1 to 1,000 bottles, and the volume can be up to 1 liter. And PP, LD, PE, and PET can all be used as blowable material.
最后我来讲一下
The final one
打印解决方案在生产
of our solution is our application in production spare parts. Haier is one of our largest clients, and not long ago they bought the largest 3D industrial printers. The printer is used for the R&D of their washing machines. But one day they found that one of their production line has a defected fan, electronic fan. If they want to, it will take them 3 months to order and buy a fan. Without such a fan, the entire production line cannot operate. But they decide to buy one of our largest printers, and the printer is really very huge, and they use PC material to print the fan that they need directly by our printer and install that fan on their production line. And the fan printed by our technology is very durable. It was used for 3 months until the fan that they order came. So this is the soft or flexible production solution that we provide to our clients. Back to production parts. Well, I would like to introduce the latest material that we developed, Autumn 1010, and it can stand a super high temperature, and it can resist any acids, and it's very flexible. It has a very high elasticity, and it has got the certification of FST USP 6, and the certification of NSF51. So this material can be safely used in food processing and healthcare industries because it can be sterilized in very high temperature and high pressure environment, and it can be widely used in food and beverage industry. Any molds used in this industry can be printed with this material.
我刚刚说的这个，比如说直接打印这么一些食品上的模具。
You know, we could 3D print some food mold, and we could also 3D print some devices like this. It's a robotic arm. It's actually 3D printed by some food-grade material, based on some food-grade material. It helps fix a camera, a sensor, and the material, of course, is food-grade, and it's 3D printed. And on the assembly line, you see a great number of robotic arms. You know, the tool attached to the robotic arm is also important. If that tool is too heavy, it will be very inefficient. So we could 3D print the tool attached to the end of the robotic arm. It helps grab the food and everything else. And you can see that on the right-hand side, the two custom-made tools attached to the end of robotic arms. The original one were traditionally manufactured from material of aluminum alloy, which is very heavy. But this one, it's very light, and it's got really aesthetic values, and it's not. And it's got some small details that cannot be manufactured by some traditional ways. And it's particularly suitable for manufacturing a small quantity of devices. And we make use of some engineering plastic. It's very hard, and it's also very corrosive resistant. And it can be very flexibly configured or set. The last one is an interesting and a simple object. That's something NASA designed for astronauts to drink water in the space. Usually, if they want to drink water, they have to drink it from a bag. But just one day, an Italian astronaut received an Italian espresso maker. So he wanted to really drink coffee from espresso machine in the space. So the University of Portland researchers started to make an R&D initiative on how to allow the astronauts to drink coffee in the space. So we did use some bio-grade glass that's 3D printed by us. It's got a bit of an opening at the front end. It could just allow the water to flow seamlessly into astronauts' mouth. Some object with a weird geometrical shape that's very hard to be manufactured by traditional means of manufacturing. The first reaction on the minds of those designers was to come to our company and 3D print them for them. Thank you very much for your time. Okay.